Cool. Just a little bit about me. I'm Derek. So I currently work at DoiT International as a cloud data architect. So before that, I worked in ANZ Bank as a lead cloud engineer. And prior to that, I worked in SEEK as a principal engineer and project lead. Basically, I worked in 2 years on GCP and 5 years on AWS. So I focus more on the data engineering side. So today's agenda, I want to cover, firstly, I want to talk about the typical workflow that you may experience in your daily job. And then I will introduce Apache Airflow to help you orchestrate your workflow. And after that, I want to talk about why Airflow is popular. That's in my own view. And after that, I want to talk about Airflow concepts, so you can understand why Airflow is popular and how you can orchestrate your workflow using Airflow. And then after that, I want to do a quick demo. I prepared a few sample decks that I created prior to this meetup, just to show you how Airflow works. And then I want to talk about how you can run Airflow. Basically, what I have now is just a local Docker environment where I can show you. And then after that, I want to talk about 2 offerings from public cloud, GCP and AWS. They all have their own hosted Airflow solution. That's also a proof that Airflow is quite popular these days. And then finally, I want to talk about the best practice for Airflow, also in my view. And then after that, I want to do a quick Q&A. If you have any questions, just feel free to ask. Okay, so quickly talking about workflow. So workflow, you can think about a lot of scenarios, but here are the examples that sort of pop up in my mind. So if you are working as a data engineer, you may load a batch file from different databases to a reporting database. So traditionally, you may use tools like SSIS or other tools to orchestrate this. And typical flow, this kind of typical flow will be running pretty much daily, often in the very early morning. And also, you may be running some query on top of your reporting database, and then after that, you want to send the reports to your stakeholder. Or if you work as a data scientist or machine learning engineer, you may be retrain your machine learning model with fresh data every day. Or if you work as a DevOps engineer or platform engineer, you want to back up your database every hour. Or if you work in let's say, an e-commerce website where you want to send recommendations to your customer based on their activity, just think about all the emails you get from eBay once you click a few items from there. And finally, there's also another on-demand workflow where you host a website, you have people register in your website, you want to send a registration email to them. So these are all typical workflows that you may experience in your job. And introducing Airflow. So Airflow is what I call is an orchestration platform, and that could help you to just write a software program to schedule and monitor your workflow. So it was started by a guy called Max in Airbnb in late 2014. And fortunately, he open sourced this goodies to the community in 2015. And now it's currently under the governance of Apache Foundation. If you know Apache, there's a incubation process. So Apache Airflow passed that process. And now it has more than 20K stars on GitHub. So if you are sort of following a lot of things on GitHub, 20K is quite a solid number. And from their GitHub page, you can find a lot of organizations that are pretty well known using Airflow, and they're pretty satisfied about the product. And they're also contributing to Airflow as well. So why Airflow is popular? Again, this is just my view. I think Airflow is popular because of Python. So traditionally, you may use a lot of stuff to, let's say, orchestrate or manage your workflow. Some people use tools like Control-M. You use XML to define a workflow, or some people use YAML to define that. So by using Python, Python is has a really friendly programming language, and you can define your workflow in Python, meaning it can be more flexible because you can use all the programming concepts in there, such as like if condition, loops, and other stuff. And also making your workflow as code, meaning it is more testable. You can do unit tests on that. You can do end-to-end tests on that. I will cover that in my next talk. And also by defining Airflow as code, you can reuse that. So in future, if you have a similar use case, you can just use the same library that you built for your previous workload. And also Airflow is quite popular because it has a lot of what I call is a battery included system, where it has all the integration available for you out of box, for you to talk to the popular database, for you to talk to the service that you may use, such as Datadog, Jenkins, Salesforce, SendGrid, and Slack as well. And it has a lot of integration with a public cloud, all the top 3. And it provides a really powerful UI. It's very informational. And also from the UI, you can monitor the progress. You can even troubleshooting, because in there you can see the logs and you can trigger and re-trigger the workflow. So that's pretty much my view about why Airflow is so popular. So here is an UI. Notice that this is Airflow 2.0. I think it was released a few months ago. It has a lot of improvement on the UI side. From the left-hand side, you can see there's a DAG. So DAG is a concept that Airflow used to define a workflow. So you can see all the, this is if you run Airflow locally, and it will show all these kind of example to you, but there's a flag, you can turn it off. And also in here, you can see the dark green ones are the finished runs, and the green ones are actually ongoing, in progress ones. And from here, you can see the recent tasks as well. And in here, there's a play button where you can manually trigger the DAG. And if we drill down into the DAG, this is one of the examples that Airflow provided. So think about the workflow that we may have. So traditionally, the task will be, let's say you have 8 tasks. Traditionally, the workflow tools that you may use, such as, let's say, cron jobs or Jenkins or other tools, you will be running your workflow, the tasks one by one inside of your workflow. But having a concept of DAG, meaning you can define your workflow and having the dependencies sorted, and also you can having tasks running in parallel. So in this case, if we say each one of the tasks, run me 0, run me 1, run me 2, takes 20 minutes. In the traditional tools, you could have them running like 60 minutes before you can run the next task. But having them defined that within Airflow, you can run them in parallel if you have enough capacity in your Airflow worker. And also this UI, you can just drill down into each task and see the logs is running, which I can demo soon. So this view is what we call this a graph view. So in here, you can see the sequence of each task. Versus there's another view, which is also very popular that people use, is called the tree view. So in here, you can see all the tasks as well that break down in a tree view. And in the right-hand side, you can see all the green and red squares. So in here, you can also drill down into each one of the tasks. So the red one means it failed for some reason. So concept. So previously, I put a lot of text in here, but then I got some feedback that people ask me, maybe I could just, draw a diagram for that. So basically, what you see now is a diagram of more like a visualized version of Airflow. So think about your workflow. It can be defined as a DAG. So inside of DAG, you could have multiple tasks. And some of the tasks, you may think that, if they can be running in parallel, that will be saving my time. So inside of Airflow DAGs, there are tasks. So the tasks are the individual things that you want to run. And how you run that, it is defined within either an operator or a sensor. So an operator is something like if you want to load a file into a database, or you want to run a bash script, you want to run a Python script, that's all defined within a concept of operator. And that thing is running once. So sensor is a different operator. It's a special one. It constantly runs tasks. For example, in here, I give an example. If you put a file into S3 bucket, but you're waiting for this file, so you could use a sensor to keep polling for the file. And also inside of the tasks, if you use an operator that is talking to an external API, in Airflow, there's a concept called a hook. So hook is pretty much like a wrapper to your call to the API, and then operator just use the hook to talking to your API. So that's pretty much the basic concept that you know, and you can pretty much use this to write your DAGs. And this is more like a thing that I put just in writing. So the next slides, what I'm covering now is just the architecture of Airflow. So Airflow has a few components in here. So Airflow has a web UI, which we just showed to show how you run that. And it has a scheduler where it schedules all your tasks. So if you trigger a DAG, scheduler will be helping you to distribute your task into a worker. And all this kind of information are stored into a database called metadata database. And from here, you can see there's a concept called executor. So executor is Airflow used to execute your tasks. So I think there are more than 3, but I list the popular 3 executor in here. The first one is the sequential executor. Sequential executor is pretty much like a really simple executor that's building within the scheduler, meaning if you want to run Airflow, you can just run 2 processes. One is the UI, the other one is the scheduler. And then behind the scene, you will use a SQLite database to store all your metadata. And then you can run everything in your scheduler. So if you work with any distributed system, you will soon realize this thing becomes a bottleneck. Then Airflow use another concept called local executor. In this case, it will be using a database other than SQLite. For example, in this case, we can use Postgres. And then the idea for that will be if you are using local executor, the things will be still running in scheduler, but it will be running in multiple processes, versus in sequential executor, it will be running for only one process. So this is still good for a simple test, but if you want to run something in a more scale level, you want to try local executor. And then if you have more DAGs and more loads to run, you want to go through the Celery executor. So this is the most popular thing that people are running Airflow in production. They use Celery executor. If you don't know Celery, just think about Celery is a thing that distributes tasks into different worker instances. And next one, I will show you how to run Airflow locally. So if you know Python pretty well, you can go through these Python virtual environment steps. The link is in here. And if you don't know Python pretty well, but you know Docker, this is the Docker way. So in here, I'll just switch to my terminal. I want to show you how to run that in Docker. So in here, I have a Docker Compose file. If I can just show that to you. So it is provided by Airflow community. So in here, basically, you can see the service of Postgres, Redis. By the way, Redis is a message broker that Airflow use, and web server as well. So basically, you download the file. What you need to do is just do Docker Compose up. So by doing that, Airflow will be, Docker will be spinned up all the containers that you will be using. And finally, it will be starting up the web UI, scheduler, and worker. So if we just do localhost 8080, this is a page that I visited before. in here, you can see the local running instance for Airflow. So if you have Docker and Docker Compose installed, this will be maybe 5 minutes for you to start up this. So in here, I put a few DAGs in here. Basically, I want to walk through a few things for you. The first one is just a really simple DAG. It has 2 tasks, start and end. So, and the code is quite easy. So in here, in the UI, you can actually see the code. So basically what I'm doing here is just calling a bash script just to do 2 echoes. So if you want to run that, like what I said, you can just trigger that in here. So you don't need to provide a variable DAG config for that. You just trigger that. So you can see everything is running here. So this is a really simple one. But if you are running, like what I said, if you are doing a data engineer or doing some data analyst job, you may need to do some ETL and reporting. So I also wrote a simple DAG, which I just put in here. Basically, you read 2 tables in parallel and then use them to generate the data, to generate the reports, and then send the emails. And I also have another one which covers another concept within Airflow. It's called a branching. So basically, Airflow has a special operator where you can sort of use a condition to branch into different scenario. So in this stack, what I'm doing now is just say, I got the data and the data is clean. Then I want to do the type A transformation. If not, I'm going to do the type B. So just to show you the code, how to define that. So you just use a branching Python operator. So in here, I use a really, a simple way to define that Python callable. So in here, I just do a lambda function, just return to the operator I want to run. But in here, you can actually put a condition in here. Just say if the data is clean, I do type A. If the data is not clean, I do type B. And finally, I want to show you maybe another DAG before we continue. So this one is a slightly complicated DAG. But if you are working on machine learning or data scientists, this may look familiar to you because the process is pretty much similar, where you have some data from source, and then you have some reference data, and you want to validate your data is good. And then you split your data into 2 data sets. One is for training, the other one is for evaluation. And then after that, you generate your model, you validate that using this evaluate data set. And then if that's successful, you store that into a registry. That's all can be done within Airflow. And of course, if it fails, you just notify your data scientist that maybe either the model code is wrong or the data is not that clean. You may need to add a step in between just to clean up the data. Yeah, that's pretty much the DAG that I have. I have a simple one which I can maybe quickly cover. So this one, this one is a dynamic DAG. You can see all these 3 tasks. If I show you the code briefly, so dynamic DAG, what I do in here is I look into a folder where I find all the SQL files, and then I do a for loop. Like what I said, Airflow is quite, Airflow use Python. So in Python, you can use loop. You can just do this kind of loop, and then you can generate 3 tasks running in parallel. So this is quite useful for people who have a lot of kind of activity where you can just write a SQL. To people who really don't know Python or Airflow, they can just write a SQL in here. And then you can write a DAG similar to this, just to loop into all the SQL file they have and then run some command that you want to put in. Cool. Just go back to the slides. Cool. So you may wonder that running Airflow in Docker is cool, and then I may need to spend some time to deploy my Airflow into stuff like OpenShift or Kubernetes, or even like in AWS where you have like ECS or Fargate or something else. Any hosted solution here? Yes, there are hosted solutions. So I list down these three things, three providers that I think are pretty popular these days. So if you are using GCP, you pretty much know there's a thing called Cloud Composer. So behind the scene is Airflow running within GKE, and Amazon also has their own product for Airflow, which is called Amazon Managed Workflow for Apache Airflow. I don't know, they should name this better. Like Amazon is really good at naming stuff. But anyway, they have this kind of thing released, I think it was released last October or November. And it copies a lot of concepts from Composer. And there's a third one is called Astronomer. That's they are a startup business. The reason why I mention them is they also provide a hosted solution for Airflow. It can be deployed to either cloud that you choose. And the reason I mention them because they are really active in the Airflow community. I think they know a lot about Airflow. So next, in this session, I want to only cover Composer and Amazon Airflow because I haven't got access for this thing. So for Composer, if you look at the architecture in here, it's quite similar to the local Docker setup. The only difference is that GCP map pretty much the concept into the cloud service that are provided. For example, if you are running locally using Postgres, they have a solution called Cloud SQL. And if you store your DAGs and plugins in your local file system, they use GCS. And like what I mentioned before, the cluster itself is running inside of GKE. So GKE is a quite powerful Kubernetes implementation. So by default, you get all the benefit that you have on GKE, except auto scaling. It's kind of interesting that when I was sort of doing the research in here, I thought Composer would be sort of naturally allow you to scale up your worker, but unfortunately, it's still a feature request that hasn't been implemented. But luckily, because it's GKE, somebody who knows Kubernetes pretty well wrote a Medium blog. In here, he explained how you can actually write some, kubectl commands, and you can actually make these things scalable. And also by running Airflow within GKE, you get all the benefit of GKE so that you can, actually use an operator, a special one called Kubernetes pod operator. That's also a built-in Airflow operator. You can just pass in a container. Passing a Docker image and then a command, then it will be deployed into this GKE cluster, become a separate pod, it will be running. So that's a built-in thing. And like what I mentioned, DAGs and plugins are deployed to GCS, and it will be running synced into Airflow Docker container. And if you want to trigger the DAG, you can do that on UI. But also, if you want to automate your process, you can do that in Composer API, or you can do that using Composer CLI. That's a wrapper for Airflow CLI. You can do like list the DAGs or trigger DAGs or getting logs or whatever information you want to get. And this is pretty much like a screenshot that I took today. Basically, I deploy in Composer, just using the console to do that. You can do that in Terraform, which is highly recommended because you want to repeat your process. So one of the things that I want to highlight in here is, so we as DoiT, we have a lot of GCP customers all over the world. So a lot of tickets that we got for Composer is actually for plugin management, which is the Python dependency. So for people who work in Python for a few years, like myself and a lot of people in here, you know that Python dependency system is not perfect. There are a lot of interesting stuff that may trip you. So in here, if you upload a few, let's say I want to install a few dependency, and then one of the dependency has a conflict with the built-in Airflow dependency, then your Composer environment will be in a bad state. So we got a lot of tickets like this. That's why I want to mention that in here. So behind the scene, when you install a dependency, Google start a kickoff a cloud build job, which essentially doing a few things such as pulling their own Composer Airflow image and do pip install in there. Once it's all good, they build a Docker container, a Docker image, and then push to your Composer environment. So if you have trouble installing your dependency, just look into cloud build logs. So you can find really useful information in there, and you can try to find out the best version that you want to install within your Composer environment. And by running everything on GKE, Composer running everything on GKE, naturally, Google doesn't really lock you from accessing the container for Airflow, which is quite cool because if you use a hosted service, often you will be blocked because you essentially put your things inside of a black box. You want to see what's going on inside of your container, you can do that. This is a command that you can find out in Google Doc. It's quite easy. You just run kubectl, and then you specify your worker, and then you can just go jump into the worker. And one thing that I didn't mention in the architecture diagram is, so Composer, when you start an environment, there's a backend Cloud SQL database, but that database is not sort of controlled by yourself. It's controlled by Google. Therefore, you cannot directly access to that. So one of the tricks you could do is you could SSH or you could use kubectl to access the worker, and in there you can do, let's say pip install SQL Alchemy, and from there you can just do the SQL query that you want. That's pretty handy if you have some kind of issue that you want to troubleshoot. So the next thing I want to cover is the security. So Airflow running inside of Composer, by default using a default service account that Google provide, but you can always specify your own service account. So if you do that in Terraform, it's quite good because you can create a service account, attach all the permission that you want, and then you create an environment using that service account. And also, it is sort of integrated with Google Cloud Secret Manager. That's a pretty handy thing because you don't want to have your secret just shown just on the console or somewhere. You want to put them into your secret manager. And Airflow inside of Composer is capable to read your secret from there. And then lastly, you can because Airflow provides a concept called Airflow connections, you can use that to talk to different service. If you want to isolate your DAGs, for example, DAG A has this kind of permission, DAG B has that kind of permission, you can always use Airflow connection to do that. Okay, so quickly just want to show you the Cloud Composer. So this is the Cloud Composer that I created. So in here, you can just link to the Airflow UI. And Google sort out all the single sign-on thing for you, so you don't need to worry about the single sign-on. And this is the access to the DAG folder, which I have that in here. So basically, what you need to do is the best practice would be you have your CI/CD tool. Whenever you run something, you create a new DAG, you create a new plugin, you feel that, that's tested, then you put that in here using, let's say, GSUTR, but that's running in your CI/CD tool. But in here, I just upload that through UI just for the time. And inside of the UI, so I hope it will show soon. So Airflow behind the scene has a service to scan all your files within the DAG. Just show that. Okay. Anyway, let's wait for a few minutes. So I want to talk about this one because if you see this version, it's a kind of a different UI from what I have in here. So this is Airflow 2.0. It has a lot of what I call this useful implementation. For example, if I unclick this, I can see a lot of DAGs. But in here, if I do the custom, meaning I find all the DAGs with the tags. But in here, it's the older version. So you can all see that. Cool. So in here, you can see the DAGs that are uploaded. It's running in here. Yeah. So this is how you upload your DAG. And also, I want to quickly point out that, let's say, inside of Airflow UI, you can see the logs. So the stuff you can do is that just click in here, you can see, I want to see all the logs. Loading. So it will be all in here. And also, Google has done an integration. So all your logs will be also pumped into Stackdriver. So if you look at the Stackdriver log, you can see, let's close this one. You can see all the Airflow logs in here as well. It is handy because in production, what you want to do is that maybe I want to create let's say a logging metrics where I look into all the errors. And then if the error, let's say more than 5, I want to be alerted. So it provides this kind of native integration for you. Finally, go back to the slides. The next thing I want to cover is the AWS version of Airflow, MWAA. Again, it's not a good name, but yeah. If you look at the architecture in here, and if you still remember what it was in Composer, you can see it's pretty much the same. Like a database is in the Amazon controlled place, and you talk to your Airflow stuff using a DB proxy. A Composer using the same thing. So the difference here, which I think is a good difference, is that when you run Airflow within AWS, it doesn't use EKS, it uses Fargate. And when it runs runs a queue service, it doesn't use Redis, it uses SQS. It's pretty native. So the beauty for here is that if you have multiple, let's say, if you have tons of DAGs you want to run every day, so each one of the tasks will be pushed into this queue, and Amazon is monitoring this queue for you. And then if the queue grows a lot, then Amazon knows, hey, maybe this Airflow cluster needs more worker. Then it will provision more worker inside of Fargate for you. And once your task is finished, it will scale down and scale down. So this is one of the things that I think Composer should add, but Amazon just did that. And same thing, you can deploy that from UI, CLI, SDK, and CloudFormation. Again, I recommend CloudFormation because you want to repeat your processing here. And for security, so Amazon doesn't have a service account, but they have roles. So you can bundle a role into your Airflow. So meaning all the workers will be assuming the role and to talk to your other AWS services. And by nature, all the things is encrypted using AWS KMS. And AWS also has their own secret manager. You can do the same thing like Composer, where you can store something within secret manager, and then you can access that from the Airflow. And again, AWS use the same concept. Instead of GCS, they use S3 bucket. So the DAGs and plugins you can upload to S3 bucket, and then it will be synced into Airflow container, and from there it can be run. And same thing, you can trigger your DAGs from SDK, from CLI, and below is just a screenshot. Oh, the other thing that I'm being interested in is just the container access. So because my AWS knowledge is a bit rusty, I guess. So I Googled a lot just to search if I can just access the container within Fargate. But I can't find any sort of, I don't know, successful story on the internet. If people who are familiar with Fargate maybe can just have a try to see if this is doable, because to me it's quite important. If I'm running a service, I want to be able to access the container, because often if you have a really nasty bug, you want to actually access to the machine and see what's going on in it. Cool. And quickly, I want to show you the environment. So this is the environment that I created. If you drill down inside of here, you can see the status in here. Again, I'm going to zoom in. You can see that the DAG folder where you put your DAGs and some networking stuff, VPC and subnet. And also Airflow has this kind of integration with CloudWatch within Amazon Web Service as well. And one thing I want to talk about is this role. Like what I said, AWS doesn't have a service concept, so it bundles everything to a role. So if you want to have your worker talking to some extra service, you can always edit this role. Again, do that in CloudFormation. Don't just manually add it. So it's all in here. So if you're interested, you can just have a look at what's the actual policy binding to the role. So in here, you have the UI access, which I have in here. So this is my Airflow instance running on AWS. Again, it's not 2.0. So one of the AWS, I think, account manager told us it should be ready end of June, but you don't know. So before that, so both cloud use 1.x. So in here, you can see there's a DAG because I uploaded in here. So again, it will be synced into the container. So you can do all this kind of information in here. So this DAG is interesting because I want to show you one concept in here. So in here, you can see I have these kind of dummy DAGs, and finally, I have this kind of list of 3 files. So if you look at this kind of permission, so I have list of bucket permission for this bucket. It's called my Airflow bucket demo. So in here, because inside of my code, what I have is I'm using a thing called Jinja template. If you are using Python or you are writing stuff in Flask, you may know the term. So basically, I'm just defining a variable using code name conf1. And then if I put a thing in the DAG run, when I trigger that, it will be read from here. So let's do that. So when you trigger that, it will tell you, hey, this is optional, but do you have a variable you want me to pass through the DAG? So this is useful if you want to sort of debug something or you want to run something ad hoc. This can be useful. So in here, I just do that. I can trigger this DAG. So you can see it's in running. So if I drill down into this DAG, so you can see this thing is still not running. If I refresh, okay, it finished. Again, you can see the logs in here. So basically in here, it says the task is successful. So I get a list of files from this bucket. And Airflow has another concept called XCOM, which is you use to pass your value from one task to another. Because I'm using the built-in operator, so by default, it just write into XCOM. So in here, you can see I have 2 things in here. One is just the folder itself. The other one is the file that I put in here. Cool. And then the last thing I want to show you for that is just the logs. So log is good. Log is beautiful because when you are running something and you're running that in production, you want to see all the logs. Therefore, like when I create this cluster, I just turn on all the logs. So by default, it only has this log, but I want to see everything. So if you drill down into the log, you can actually see all the runs in here. Yeah, everything is just in here. Cool. Go back to the slides. I still have, I think I have 2 pages. So best practice. So everybody in there love best practice. So I'm fortunate enough to work on Airflow for, I think, nearly 2 years. Some of my experience are here, so I just want to quickly talk about it. So firstly, because the DAG is defined in Python, and personally, I prefer readability over code abstraction. But we could talk about this after this chat. The reason I saw readability is quite important is just because normally when you write a DAG or you implement your workflow, you may move on to another thing. Then other people is supporting your workflow or your DAGs in Airflow. Then he or she need to be understanding your things quite easily by reading your code. So to me, readability is quite important. And also, if we could have some abstraction, for example, what I have an example in there where you can use a for loop to create 3 tasks in parallel, that's also good. And the second thing I want to talk about is one of the things that people may do, but I think it's not good. So think about the diagram that we have. Airflow has a concept in worker. So basically, if you run something in Airflow, it will be executed by the worker. So it would be good that if you can have the compute happen on the cloud or in another place other than the worker itself. Because in my experience, I saw somebody try to do an encryption for the file within Airflow, which is quite bad because encryption takes a lot of CPU and memory. Then if you're running that, other task will be blocked because the worker doesn't have any more resources. So keep in mind, if you're running that, try to run things outside of worker. So worker can be trigger a task in the cloud and let other things running in there. So this is also really good because Airflow provides a Kubernetes pod operator so that if you want to isolate your computing, you can kick off a task within your shared Kubernetes cluster as well. And the third one I found useful is that Airflow has a really huge community. They create a lot of useful libraries in there. And often they are the people who actually eat their own dog food, meaning they tested the libraries themselves and they contribute to the community. So think about like some of the scenario where you read a file from S3, you download from S3, or you write to a database, Athena, or you write to BigQuery, whatever, they all have libraries within that. So basically, before you actually create your own thing, check if the community has that. The benefit for that is like first, it's more robust often. I wouldn't say 100%, but often it's more robust than what you come out with because they cover a lot of edge cases in there already. And secondly, you don't need to do a lot of testing for that because the community help you to do that. This is what I call a beauty of open source. Just leverage what I do. And once you find the bugs, just fix the bugs, send the PR. So I personally send a few PRs in there and they are really kind to accept the PR and they are really responsible and help you to address your issue. And then the fourth one to cover is that people may think that Airflow is really good, maybe it's also suitable for non-technical people, such as some high-level management. You want to show them your workflow. You want to show all the green circles that you have. My experience is that it's not that good for non-technical people because they will come back to you and ask you, hey, what is the DAG? And explain to me what is the DAG. Then you need to do your homework and do a lot of stuff and explain how it works and stuff. So what I prefer is to use the data from Airflow, actually generating your own dashboard to the stakeholder because often they want to see the trend. They want to see like all your workflow running all good. Even though there's some error, you can explain what's going on just within the custom dashboard. And lastly, this is also an experience that I have running Airflow in production. So I had an experience running Airflow in production, supporting, let's say, 30 or more than 30 datasets and using the same DAG. Soon I realized it becomes a support nightmare because people who are in support will talk to me, hey, I don't know what data load failed. Then I started to think about, oh, maybe there's like a solution for that. And there's a solution in actually, when I Google that, I just say, hey, can I dynamically create a DAG? Yes, you can because it's Python. You can create a function. In this case, you create a function which will return a DAG object for you. And then in there, you can do a loop So in here, what this code snippet does is just to generate 10 decks. But often you can do just say, I want to loop into a list where it's all my dataset name. I can then create dataset, let's say load data A, load data B, other than I have a deck called load data. Yeah, because that will make your support people happy, because they look into the deck, they know exactly what data load failed. They can just straight away look into the folder if the file is missing or the file is malformed. They can, save a lot of time for them. And finally, testing. It's quite important to testing your deck. And because it's Python, you can use unit test framework to test that. You can also test end-to-end. And these are the subjects that I want to cover in the next meetup. In the next meetup, I want to have some kind of more like a generic business requirements that you may have in your life, in your daily life. And then I want to sort of just work with you just to break down the task, and then write the decks, write the custom plugins, and then write unit tests for that, write end-to-end. That's pretty much like a full circle if you want to work with Airflow. Finally, is Airflow my only option? Short answer is no. There are too many other tools. So if you are happy with Chrome tab, you have like database backup in Chrome tab, it works for you, good. Just don't change that if that's working for you. If you have Jenkins, like you have tasks running sequentially, like the time doesn't really matter because it's a backup process, then just use Jenkins. And if you have experience in Cloud Build, you may want to just say, hey, I want to load data using Cloud Build. Previously, I would be thinking about, that's a CI/CD tool, why you use to do that. Then, I see people having good story about that. So yeah, Cloud Build is also good. And recently I heard a tool called Argo. So Argo has a lot of good things. So it has also have a good UI and it's cloud native on top of Kubernetes. So if you are really deep into Kubernetes, maybe Argo is a good choice for you. And also in AWS, there's a thing called step function. If you have a really simple workflow, such as, let's say registration, somebody registers something, you want to automatically generate a password for them, maybe step function plus Lambda is a better solution than Airflow, because you want a timely sort of workflow.